So this is actually a block problem. So I'm not sure whether you play this game or not, where you have to actually place on the block. You have an A, B, C, D, E, 5 block here. So you have to place the B, E, place stack the blocks one to another, and until you reach A, B, C, D, E. In this case, I don't really encourage you to perform the blind search using solve this problem using a blind search. So it's going to give you a very long state space, and it's not effective at all. And how are you going to define the successor function also and other problems? So this one I will keep it for the heuristic search, which is the informed search. I will show you how to use the informed search to reach the solutions. I'm not going to use the blind search now. It's not effective. So I will skip this question 3 for next week. We have so after we have a depth first search and breadth first search. So there's another search. It's called depth first search. Okay, so in the depth first search, there might be one problem or the limitations called infinity loops. So in some state space, okay, you might have some solutions or the state space look like this. Okay, it's in a cycle, or sometimes it is infinite. Okay, so something like this. So you have a very big state space. This is like we call it as a infinite graph. But using the depth first and breadth first search, yes, we can read you to the solution if, let's say, the state space is finite. Okay, but sometimes you might have infinite path. If let's say if you have an infinite path, by using depth first search, you may not able to lead to the solution. It means that you have to keep search, right? You search, keep track inside here, or maybe infinite, you search until there's no solutions. It might happen. So in order to avoid this kind of so-called trap inside the loops, so someone introduced the depth limit search to avoid that trap inside the loops. So how the depth limit search is where we have to set the depth first. Okay, this is one of the parameters. So let's say D is equal to 5. So we will do the search only. This is level 0, level 1, level 2, level 3, level 4, and level 5. If there's no solutions, we stop there. We don't continue the search. Okay, we don't continue the search, we do backtracking. We search. Whether if there's solution, no more. We backtrack, search. Okay, we set the limit D to a certain number to avoid trap inside infinity loops. Okay, but the problem for the depth limit search is, how do we define the D? We don't have any standard way or any so-called any guideline to set what is the proper value for the D. So this one we have to try and errors. So in order to solve this depth limit search, someone developed another solutions. Another search is called iterative deepening depth first search. So what is iterative deepening depth first search? So come back to the depth limit search. So iterative deepening depth first search is where we set a D as well. Okay, for example, D is equal to 5. So we search. If there's no solution, for example like this, no solutions. Okay, search. Okay, search. No solutions. Then we will open up this limit. We will add the iteration, maybe increment by 1 or maybe by 2. Then we continue the search again. Let's say now we add to D equal to 7. We add the barrier search. If there's no more solution, add more, maybe 1 or 2. You iterate. You add the D value. We increase the value of D. Okay, so not very important now. And then the last search is called bidirectional search. So what is bidirectional search? Is where we do the search in two directions. Let's say now we have a initial state. We know that this is our initial state. We know that this is our goal state. So we'll expand from here. Let's say you have a 3 nodes. So goal state, you can backtrack. It's actually reach from maybe another 3. We do concurrently. Then we continue the second level. Maybe this is another level. This is 1. Maybe this is that end. Maybe this is that end also. Maybe this is come from the 1. So this is another 1. This is another 2. And then we continue. Maybe this meet to this part, right? So this to go to other way around. Okay, this go to others, this go from others. So then we know that this will be our solutions. We start from both directions. Okay, we start to expand and then we backtrack, and then you somehow have a center point or you have a intersection point. Then we will stop the search. Okay, is that clear? So, but however, these 3 search are not very famous for the interactive tab limit search and also bidirectional search. Okay, as long as you can understand the depth first search and breadth first search, that is good enough. Okay. Okay. So, any questions so far? If no question, then I have a question for you. So, can you try this question? It's one of the past question back to 2022 October. So, can you try this? So you have a 2, 4, 6, 7. You have a 7 nodes here. Okay, design automated driving car. You would like to start from A. Your destination is G. So assume that all distances are equal, but in this case, we don't care about the distance because this is blind search. So look at the question A. Suppose agent Jack is required to drive from A to G. Using breadth first search and depth first search, draw resulting search tree with the node expansion in alphabetical order. Okay, and at the same time, find the return path. Okay, so I give you 10 minutes. Try this question, then I will know your understanding, whether you understand this depth first search or breadth first search. 10 minutes, 10 minutes. Sometimes try to sign again. See whether you are able to sign again. 9019666.